Hi, it's time for another math easy solution. We're going to discuss, I'm going to go back to direct substitution and now look at a proof for polynomials here. So basically in my earlier video I introduced this one, also did examples on direct substitution, but I didn't really prove it. So now if I just recap on this, if f, the function f here, is a polynomial or a rational function, see video link below on polynomial and rational functions. Well, I'm going to go over this again. And basically an a is in a domain of f. So basically a is defined here. When you plug it in, you're gonna actually have a function here. Then basically the limit as x approaches a of f of x is just equals to f of a. So all you do is just plug this in here, and it's only for polynomials and rational functions here, this property. And also I showed before that functions of direct substitution are continuous, meaning that they are defined at it, and not all limits can be evaluated by direct substitution, such as this one. And you can see a video link below. I did this previously, because if you plug it in, you're going to get a 0 over 0 or divide by 0. You can't do that. You can see a video link below on how to solve these. But now I'm going to look at a proof for polynomials right here. Yeah, and then in the next video I'll do it on rational functions here. So for polynomials, what I mean by this, so if I recap on polynomials, this one's just defined as just this function p of x. All it is equal to a0 plus a1 times x plus a2 times x squared plus a3 times x3, etc., all the way to n. These n are integers, where ao to an are just constants here, so they're not variables, so they're just a fixed number, etc. here, but then the n ones are integers. So if you have something like this right now, so what we have to do is show that limit as x approaches a of a polynomial of f of x, we all have to do is just show that it's equal to p of a. So now the proof for this, is straightforward. We're going to apply the limit laws. You can see the video link below on that. And basically, if we just prove this is direct substitution. That's all it is. So now let's just write down the expanded polynomial form. Yeah, so basically we write this down here. Limit as x approaches a of p of x. This just equals to, we just plug in what the definition of polynomial is. Just a general one like this. So we have something like this. And then using the limit laws, we could break apart every single one of this. So we could write this as limit. Yeah, so using a limit law, we could break apart this, and basically this limit of this sum is just the sum of all these limits. And now for all the constants one right here, we could just take it out. It just becomes the constant. Yeah, so then this one is going to be a0 plus this one here. We just take the constants out, so a1 limit x approaches a of this one here, then similar for all of these. Yeah, so we get basically something like this right here. All the constants are out, so we have limit of this. And also in the limit laws I showed, I just showed the limit law where if you have something like this, just any x or x to the power of n, any power. So the power law, or in terms of limit laws, this is just, it becomes well, for this case here, it just becomes a. This one's just going to be a squared. We just plug it in. So these ones have a direct substitution property inside. The proof for this I'll show them in another video, but basically, so we have this from the limit laws, and then we're going to just sum all these up. We're going to have a1, this is going to be x plus, not x, the x becomes a, so then a2, a plus a3, a, etc., all the way up to an, and then this one's going to be a. And this just equals to, well, if we just plugged it in here. Actually, let me just put these squares here. This is squared, cubed, this is to the power of n here. So then this one here, this is all this is just plug it in p of a inside it. So we've just proved this one here. So this is a proof, but I haven't really done the direct proof of this, but I just went over this a bit in my earlier video. You can see a video link below. But I'll prove all these the limit laws in another video. Well, that's all for today. Hopefully you learned from this video. Remember, you can always download these notes in the Dropbox link below, and also I'll do another video on rational function, just to prove that with direct substitution property, prove it for that. Well, that's all for today, and yeah, hopefully you enjoyed, and stay tuned for another math easy solution.